Hey guys, so I'm going to go over the build of the ultralight, and I took some pictures along the way. I probably should have taken a lot more, but these things usually take endless hours and there's always interruptions in between. Um, so I tried to take as many pictures as I could, but there's definitely some big gaps in it. But anyways, I'll try to do my best to kind of explain the build here. So this first picture here is basically where it started. This is two sheets of foam board basically taped together. And then I have a 1/4 inch by inch and a quarter solid piece of wood that I'm going to use as the spar that I'm going to end up standing up on end. What I did with this wing is I was trying to make it about as big as possible. So it has a 15-inch cord, so it's a pretty large wing. It's a 15 by 60. So here I measured out where I wanted the front of the wing to be, and then where my spar needed to be, so that I could make the airfoil that I wanted for this wing. And so that's what I did here. You can see there's about a 2-inch spacing between the front of the spar and the front of the wing. And then in the next one, you can see I have the spar up on end and then also a piece of foam board behind it, which is the same size. That is basically a support for the wood spar that I put in there. And then also the wood spar that I had wasn't long enough to go the full length of the wing, so I centered it. And then the last, I think last 6 inches of the wing on either side are foam, which is more than strong enough. But the majority of the wing is the wood spar, and this is a super strong wing. It's definitely stronger than it needs to be, especially with the structure underneath holding the wing up. It's a really strong wing, and it's pretty light too. So here you can see I put a dent. I actually take the razor blade and I cut the very top bit of paper, and then I also use the end of my pen, and I'll basically make a crease all the way down the cut, and this is where I'm going to bend the front of the wing. On the other side, which you can't see in the picture, on the other side of the foam board, I also have a strip of clear packing tape on that hinge, basically, so that when I fold it, it stays nice and strong. So that's what I'm getting ready to do here. In hindsight, I probably, in a lot of my other wings, a lot of airfoils, what I'll usually do is I'll actually pull the paper off on either side of the crease that I'm going to do there. That way the foam can actually bend and the airfoil can be round. In this airfoil that I did on this wing is more like a flight test airfoil where they kind of have a sharp angle to them, kind of like this one, which still works just fine. But usually I would pull the paper off so that I can make a rounder airfoil. Not that big of a deal. It works great either way. But let's go on to the next one. So here you can see the wing more finished. And I wish I would have taken more pictures because there's quite a bit more to this than what you can see in the picture. Basically, if you look closely, you can see there's a piece of foam board in the middle that's going to the left from the spar. That's the main piece of foam board that I did. That's the solid sheet. And then on top of that, to make the airfoil longer and make the wing overall longer, I put another full sheet of foam board down and I glued the top edge of it right above where the wing spar is. And then I let it hang off the edge about 3 inches. That way I have 3 inches for the ailerons and the flaps. So that's what's going on with this wing. And then I glued the top edge and the bottom edge. And then I also taped the top edge. That whole entire edge is glued and taped. So it's really strong. That's what I did with the wing. And that's basically the wing finish there. It's crazy simple. It's basically 4 sheets of foam board, so it's a good amount of foam board, but it's really strong, and it's a really large wing. Here you can kind of see the airfoil shape and the structure on the inside with the 2 pieces of foam on the end. And then the one main piece of foam where it goes across the bottom and then across the top and then bends to the left. And then there's a new whole other piece on top. And then here you can see drawing out the entire fuselage. So here, this is all made up. I mean, the whole thing is made up, but here I basically looked at a picture or a few pictures of the Airbike 103 and just kind of got an idea of what I wanted this thing to look like. And then I started making up the proportions, just kind of going through in my head what would look good, what would work well with the wing as far as like having the fuselage size, what would be too big, what would be too small, and just kind of kicked around some ideas in my own head and thought about it. And then once I figured out what I wanted to do, I drew it out on paper. So here, this is all drawn out and ready to cut. After I decided the angles of everything, just kind of messing with a few different ideas, I drew the whole thing out and cut it out. What I did with folding the fuselage is I actually scored the front part, all of this whole front part where you can see all the solid lines are. All those are scored so that the front part of the foam board paper is cut, but the backside isn't, and the whole entire backside is taped, so it's nice and solid and strong. And then what I did is when I put it together, which you'll see in the next photo, I actually folded it back on itself, and then I glued in all of the structure. And everything in here, the whole bottom is triple layered all the way until like halfway through the fuselage towards the back. And then the rest of it is double. So the sidewalls are double thickness, and basically the whole bottom around where the battery tray is, the landing gear is all triple layered, and then the rest of it's double layered. So it's super strong and pretty light too, considering how big it is. If you look closely up towards the front, you can see the battery tray that I put in there. I originally designed this plane to run with a 6,000 milliamp 3S, so the battery tray is pretty large. It's also really strong. That's also double layered as well. So the whole front of this thing is super strong. But I wanted the battery to be as far forward as possible just to make sure I had proper CG, because this is such a big, heavy, long plane that I wanted to make sure I could get the battery as far forward as possible. And I also did the math and figured out pretty closely where the CG was going to be on the airplane wing, and then based on that, I knew where the CG had to be on the fuselage, and that's where I basically put some weight in the back where the tail would be, and I balanced it, and I got a really good idea, a really good rough estimate where the center of gravity for the wing had to be, and then based on that, I could put my battery tray in and all the other parts. So here you can see I've got the tail put together. Basically, this is about 1/4 size of the wing, and that's what I did for the horizontal and vertical stabilizers. The vertical stabilizers are about an eighth the size, so it's half the size of the vertical or horizontal stabilizer. And then that's basically kind of like a rule of thumb that I went with on this one, and what I've kind of done on most of my other planes. Sometimes it's a little bit less, but this is such a big, heavy plane. I also wanted it to look more scale, so I went with about 1/4 the size of the wing width on the tail surfaces. Here you can see I finally have the wing mounted up. This was kind of hard to figure out and kind of a pain to do. I was using tape measure to make things as square as possible when I did this, and you can't see it in the pictures, and I'll see if maybe I can do something on this in the future, but there's actually inside the wing on the underside where the front and the back mount up in this picture, you can see I actually cut the foam out on the bottom side and glued in wood on the inside of the wing. And then with the wood struts, you can see in this picture, they're actually attached to wood that's a thin piece of plywood that are inside the wing. And then all that's hot glued together as well. So it's got wooden structure for all of the wood dowels to attach to. So it's not just foam, it's also wood. So it just makes it really strong. Here's another picture. You can see I've got the motor mount on there, and just another angle of getting the wood structure, all the dowels figured out on these. I was going to use 1/4 inch dowels, but I just didn't think they were going to be strong enough. So I found 3/8 dowels at my local Walmart. It was like 78 cents for each, so it was like a few dollars, and I got all the dowels I needed. So I just decided to go with that. Really, no other reason. They were super cheap, and they're about what I felt like was going to be the right size to make this look right. Here, I'm putting in the dowels. They attach the wing to the fuselage, and also they stabilize it as well. What I decided to do here is I went to the strongest part of the fuselage and also try to make this look kind of scale, because this is sort of how the real ultralights look. Um, I was trying to go to the strongest part of the fuselage. What I did here is I basically poked holes through the double layer of foam and then pushed the dowels all the way through to where they hit the floor, because it's triple layered there. And then I glued those in with lots of glue on both of the dowels on both sides. And then I pushed the dowels down into the wing, and I cut the wing out where the dowels would land. And I put hot glue on the inside of the wing, and then also put the dowel in, and then glued the dowels to that. So it's like a double layer of hot glue on the inside of the wing and on the outside. So there's more than just foam there. There's a kind of a puddle of hot glue there that adds a little bit more structure, and it just made it really strong. Here's another picture of it from the side, where you can see the whole wing is mounted up. I think it turned out pretty good. This actually was pretty strong the way it is, and later you'll see some more pictures where I added 2 more dowels to the wings going from the back. Now the real plane doesn't have these, at least none that I've seen, and maybe they might have them at a different angle. But I decided to add extra dowels coming from the back of the fuselage because the wing was strong and it was pretty solid, but I felt just a small amount of you can move it just a little bit. You could tweak it just a little bit side to side. On the y-axis, you can twist it just a tiny little bit, and it probably would have been 100% fine, but it was the one thing that kind of bothered me about the wing attachment. I didn't want to risk having like a bad landing and then the wing getting ripped off, because it twisted just a tiny bit. So this is something I ended up changing in the future. Here you can see the size of the ultralight next to my 60-inch Blue Thunder. So they're both 60-inch planes, but they're just totally different. It's pretty cool to see them side by side. They're such different planes. Here's another picture where I'm looking down the front of it, so you can kind of see how the webbing is on the wings and how it's held together. We have the tail wheel, which I ended up changing, but this is basically just 2 really thin pieces of plywood glued onto the center of the tail of the fuselage where it's the strongest. And I bent some thin steel wire so that I can make basically a bracket for the wheel, and that's pinched in between 2 pieces of plywood so it's nice and strong. And then that's all hot glued to the tail. This is the landing gear finished. I've done the landing gear a couple times already. This first landing gear that I did was fine. It was basically based off of a flight test landing gear for the, what is it? It's the XL Scout. So it's basically a super simple, just wire landing gear. And it did okay, but I think the first or second landing, it bent, and it just kept bending so easy that I had to come up with a different solution. So here, wiring up the plane. So I think in the future I may do this a little differently. Some people will wire up all the servos while they're building the wing, so everything's kind of hidden inside. I guess I could have done that. When I first started building this, I wasn't even planning on building this. Sometimes I'll just put a wing together and just let my imagination go, and I'll just make something. But since I didn't do that, I decided to wire everything up. But this is something different that I did on this plane that I haven't done on most of my others, is I'm actually running all the wiring inside the wing, which wasn't too hard to do because it's such a big open cavity inside the wing that it was pretty easy to set up. So I ran all the servo wiring and the extensions through the wing and then out the center, and then actually zip tied them to the top of the wing on the underside, then zip tied them down all the dowels that connect to the wing. So it looks fairly clean. I have some pictures of the ultralight all finished up, all taped up. I actually wanted it to be red and white because that's the color of one of the planes that I seen online. But I was out of red tape and I had a bunch of green, so I turned it green. So here we have the finished plane. This is just the other day. I decided to change the landing gear completely because if you guys saw in one of my more recent videos, I ripped off the landing gear due to the plane losing power, and it just made a really rough landing. So it ripped off the landing gear, which is fine. I'm glad it happened because I ripped off the landing gear, and just for the fun of it, I decided to weigh everything with the big wheels and everything in it. It was like around 240 grams just for the landing gear alone. It's a ton of weight. So I was thinking I need to try to make this thing lighter. So I had already ordered some tiny 2.5 inch wheels that I wanted to put on this thing originally, but I decided to go with bigger wheels just because I thought maybe the little ones were a little too small. But I decided to use these ones to save weight. And also, if you look at a lot of ultralights out there, they have itty bitty little wheels on them anyways. So it kind of goes well with the theme. So you'll see on here that sort of like the last one and a couple of the more recent videos you guys might have seen, I used some 3/16 plywood to beef up the stainless steel 1/8 inch rods that I'm using, just to kind of act as a suspension with between the plywood and the glue. It acts kind of as a suspension for the metal, and it allows it to bend a little bit and kind of spring back without breaking. And it's also much lighter. I'm not sure how much this landing gear weighs, but I'm gonna guess it's at least probably 50 to 75 grams lighter. So I think it's going to work out really good. It's going to look good, and it's also going to save a lot of weight. So that's it for this one, guys. This is a super long video, kind of going over a bunch of details. Um, if you guys have watched any of my other videos, I try to talk about as much as I can so you guys can hear more about some of the other details as far as the motor and all the different props that I've tried, the batteries, and all the little things that I've tweaked to try to get this thing optimized to fly as good as it possibly can. This has been a really fun project, probably the most ambitious project I've done. It's all kind of made up as I went, and I kind of had an idea of where it was going, but it's taken a lot of time and experimenting to get it where I want it. But it's been fun. I finally think that I have everything dialed in, and it's just going to be something that I could just fly and enjoy. And I look forward to flying it a lot more. And if you guys have any more questions about this build, I'll be happy to answer them. And thanks for watching. I'll see you in the next one.